Hello. Alright, this will be the second video for existence of limit, the concept of existence of limits. You know that limit exists only if and only if the two limit here, for example, you want to find the x approaching 1 for hx. So for this type of function, either a modulus function or piecewise function. Alright, as you know that modulus function can be written as a piecewise function. So because they have different function after they across this boundary value here, right? So it means that 1 plus the function will be different, 1 minus the function will be different. So this type we need to consider whether the limit exists or not. So for example, these cases 1 to the right, okay, to the right. This is a number greater than 1. So it will be limit x approaching 1 from the right, which will be 2 plus x squared. So you can direct substitute. So 2 plus 1 to the power of 2, you're getting 3. Right? You're getting 3. So how about from the left, approaching 1 from the left? So from the left is a number that less than 1. Right? So I'm choosing the function 4 minus x squared, right? 4 minus x squared. So you substitute the value of 1. So 4 minus 1 to the power of 2, you are getting 3. Then you can see that the right hand limit you have 3, the left hand limit of 1 you have 3 also, right? So both the value is of the same. So means that the limit as x approaching 1 also 3 exists. The limit exists. Exists means there is a value, right? But if these two values are different, then there are no value for this. So it's just state does not exist. So this is a from the algebra way. So algebraic way, you know that the graph is continuous from this means that this graph will join this graph. We're joining this graph at this point, means they are joining, okay now. So joining means that they may discontinuous, but they are actually have the same limits from the right and from the left. So if you see that the graph y x 0, so as x approaching 1, right? X approaching 1, x less than 1. So when x less than 1, the graph will be 4 minus x squared. The graph for 4 minus x squared. So it will be passing through 4. So means the graph will be look like this way, right? It will going this way. So then they will stop at 3, right? Because when you put the value of 1 inside here, 1 square, 4 minus 1. So during x is 1, the value is 3, right? So it will stop here. So suppose the graph complete will be 4 minus x squared, right? 4 minus x squared. Alright, let's look at the graph after 1. After 1 is x squared plus 2. X squared plus 2. So x squared plus 2, the graph will be, the graph for x squared plus 2 we're looking like this way, right? So because they just want 1 after 1 means x more than 1 after 1. So I only want this section here. Alright? So what is the value here, right? So I have to substitute the value of 1 into the function here. So 1. So 2 plus 1 square, you have 3. 3. So the graph is starting from 2. So the graph is supposed to be looking at this like this way. Then later they were going this way, right? So you can imagine that I'm taking this graph and I'm joining here, right? If you look at this graph here, the graph is not break. It's not break. So it means that limit exists. This limit exists here. So from the left, 1 you have left and right. From the left, approaching from the left, you're reaching value 3, right? They're going to the value 3. Can you see that? Right. From the left, you get 3, right? 1 minus. From the right, So from the right, you also going to the value 3. That's why they are not break. Yes or not? So this is the meaning of limit exists. This is the meaning of limit exists. So let's look at another example. Alright, let's continue with this example. So in this example, I'm going to asking you, does limit exist at x equals to 2? And does the limit also exist at x equals to 4? Means that there is a change of graph. Before 2, this is the graph. After 2, that is the graph. Right? Before 4, there is a graph. After 4, there is another graph. Now means that we have to check the value of 2 and 4. First, we look at 2. Does limit exist for 2 or not? So means that the existence of limit. Now we refer to 2. Alright, the first case we refer to 2. So I hope you understand. After I give you, this is the third example. So okay, so now x equals to 2. So we have to determine whether the right hand limits, the left hand limits, before we decide whether limit exists at x equals to 2. So, okay, to the right, 2 plus x greater than 2, right? This is less than 2. 2 from the right, apart from the right, means that a number that greater than 2. So, will be 2x plus 5. Alright, so you choosing, then you calculate, you have x approaching, then you 2 multiply 2 plus 5, you're having the value of 9, right? You're getting 9. So 2 from the left, x less than 2, right? So will be x cubed plus 1. So you substitute, you're getting 2 power of 3 plus 1, you are still getting 9, right? 9. So and I can conclude that limit as x approaching 2. Therefore, limit x approaching 2 for this function, even though the left hand side, the left of 2, the function is different from the function after 2, right? It's different. So, but the limit do exist, which is the value of 9. Because these two values are the same. They are equal, they are the same. So, the right hand, the left hand are the same. So, I can conclude that approaching that value of 2, the limits will be 9, right? So let's look at 4. Now we're looking at 4. So does limit exist at 4, right? So we have to consider the right hand limit, the left hand limits before we decide. So to the right of 4 means x greater than 4 will be x squared minus 4. X squared minus 4. So you substitute 4. 4 squared minus 4. You have 16 minus 4, which gives you 12. Right? Okay, how about the left hand limit? The left of 4. This one. Less than 4. X less than 4. So 2x plus 5. 2x plus 5. So you replace the x with 4, substitute the x with 4 plus 5. Then you have 2 times 4, 8, 8 plus 5, you have 13, right? You see that the value is different. So it means that limits as x approaching 4 does not exist. Why? Why does not exist? Because if they ask for the reason, it's because the limit of x approaching 4 from the right for fx is not the same as the limit as x approaching 4 from the left, right? These two limits exist. This right hand limit exists given 12. The left hand limit exists given 13. But the value is different. So that's why can make conclusion that the limit does not exist. Don't have value represent this one. So, alright. So I was sketching the graph and let you see why limit exists at 2 and does not exist at 4. All right, I want to show you graphically. This is extra knowledge. All right, this is extra knowledge. Okay, I just want you to know better what is the meaning of existence of limits. So now I'm going to sketch the graph. This is a piecewise function graph. So you have 2, 1, 2, 3, 4, right? It's a boundary value. So before 2, this is the graph x cubed plus 1. So the graph for x cubed plus 1, you know, will be looking like this way. It's a cubic graph, right? So when you're putting the value of 2, 2 power of 3, so when x equals to 2, so your y will be 2 power of 3 plus 1. So it means it's 8 plus 1, which gives you 9, right? So 2, you will getting a value of 9. So you roughly know that there's the graph here, but I put an empty circle because actually 9, you put 2 because there are no equal here, so we cannot accept the value of 9, right? But we just use that point as a reference. So 9 not include. So 1, right? 1 will be the y-intercept. So the graph for cubic is supposed to be this way. You're looking at my hand, it's moving this way, right? But we just want the one that this is a 1, we just want part of it. Okay, we just want part of it. So it means start from here and drawing. So this is the graph, right? This is the graph before 2. Before 2. So it's an x cubed plus 1 curve. So how about 2x plus 5? It's between 2 and 4, right? It's from 2 to 4. So it means from 2 to 4, it is a straight line, right? It is a straight line. So when you substitute 2, into the equation, so when x equals to 2, so y equals to 2 times 2 plus 5. So you have 2, 2, 4. 4 plus 5, you have 9, right? You have 9. So exactly during 2, then this hole is filled up now. It's become solid. Because why? Because this function not accept, but this function accept, right? When you put 2, you're getting 9, right? So it's become solid again. So 4, you substitute 4. You substitute 4. Because this is a straight line, you're just using these 2 points. You need 2 points to draw a straight line. So when x equals to 4, so your y will be 2 times 4 plus 5. You were getting 13, right? 13. So during 4, okay, I have a sketching. Let's say you have 13 here, right? 13. So it will be 4. It will be at 13. It's an empty circle. So it's a straight line. It's supposed to be a straight line that passing through 5, right? Passing through 5 because there's 2x plus 5 here. So this is a straight line. So later we draw the graph of x squared minus 4, right? X squared minus 4. So you substitute the value of 4. You substitute the value of 4. 4 squared minus 4. 4 squared minus 4. So just now 4 squared when x is 4. So your y will be 4 squared minus 4, which is 16 minus with 16 minus with 4. 16 minus with 4, you have 12, right? So means that during 4, the value will be 12. Will be 12. So 4, it will be at 12, right? It will be at 12. So you look at this one. This is a x squared minus 4 graph, right? X squared minus 4. X squared minus 4 graph is supposed to be negative 4. X squared minus 4. So means during 4, so the graph will be starting from here, right? Starting from here and go up, right? So it means that there is a quadratic that passing through x squared minus 4, right? But we only want the part that after 4. So it will be looking like this way. It's a quadratic. Alright? So now you can see y limit exists at 1, right? Y limit exists at 1. So limit as x approaching 2 For fx, refer to the solution just now, approaching 2, then you are getting 9, right? Getting 9, the limit exists because the left hand limit 2 minus from 2 from the left and 2 from the right, approaching 2 from the right. So they were reaching the value of 9. So limit exists here. So but you look at this one. You look at this one. So approaching from the limit as x approaching 4 from the left. The value just now that you find will be 13, right? So as limit as x approaching 4 from the right, you're getting 12, right? From the right, getting 12. From the left, getting 13. So means something wrong here. Something that this graph is break, right? They are break. So they are discontinuous. Alright? They are discontinuous. So now, okay, according to here, now you know that limit does not exist here, right? So limit as x approaching 4 for this function fx does not exist. Does not exist. So that's the meaning in graphical way. Alright, so hope you understand the meaning of existence of limits.